In this video, we're going to talk about both sections 5.5 and 5.6, as these sections cover the same topic, integration by substitution. If you are moving on to Calculus 2, this is going to be a very important topic. You'll use this method a lot in Calc 2. All right, so integration by substitution is basically a method that we're going to use to find antiderivatives in cases where the chain rule might have been used to get that derivative. All right, and this section is so important. That's why you get baby Georgie. That's her when she was, I don't know, maybe 3 months old. And so let's just take a look at some examples. So we are going to start by finding the antiderivative of cosine of 3x. And I'm going to explain the method of substitution just through this example. So step 1, we are going to choose part of the integrand, so part of the thing inside the integral, to be our u. Usually we are going to select the inside function, just like when we first learned what the chain rule was. We let u equal our inside function. But we'll talk a little bit more about how to pick the u. Sometimes you just have to guess and see if the problem works out. All right, so inside function is 3x, so I'm going to try that for my u. So that's step 1. Step 2, I'm going to compute the differential du. We learned back in section, I think it was 4.2, that the differential, or the change in y, is defined to be the derivative, f prime of x, times the change in x dx. So in this case, if u is 3x, du would be the derivative of that. So the derivative of 3x is 3, and then times dx. Once you have your u and your du, then your next goal is to try to rewrite the integral in terms of u. So we don't want to have any x's left in our integral. We want to rewrite the entire thing in terms of u. Okay, so what I'm going to do is I'm going to take my differential, the du, and I'm going to solve it for dx. So I divided both sides by 3 to do that. If du is 3 dx, dx is du divided by 3. Then I'm going to plug things into that integral. The 3x was my u, so I've got cosine of u. And then I'm going to replace the dx with du divided by 3. And so now I have an integral that's in terms of u only. There are no x's left. That's important. And so since the integral is in terms of u, it's now actually something that I can integrate. I can find the antiderivative of this. And so what I'm going to do is that du divided by 3, technically that's a 1/3 with the du. And so I'm just going to take that 1/3 and pull that out front. And now I'm left with cosine u du. And I know what the antiderivative of cosine is. So the 1/3 stays there. Antiderivative of cosine u is sine u, and then plus c. So that was step 4. Once we got our integral in terms of u, we were able to find the antiderivative. And then finally, I'm going to write my final answer in terms of x. So I'm going to be replacing that u with the 3x. And there's my final answer. All right, let's do a couple more examples. So here's example 2. We're going to try to find the antiderivative of x square root of 1 minus x squared. So step 1, I'm going to pick something to be the u. So what do you think the u should be? I would try 1 minus x squared. That's inside the square root, so that's a good starting point. Once I pick the u, I'm going to compute my du. The derivative of 1 minus x squared is negative 2x, and then we tack on a dx. Now I'm going to see if I can get this integral written in terms of u only. So I'm going to take the expression for du, and I'm going to solve it for dx. I can do this by dividing both sides by negative 2x. So divide both sides by negative 2x. And then I'm just going to plug things into the integral, and I'm going to hope that the x's disappear. So let's see what happens. So we've got that x in front of the square root. We haven't done anything with that yet. And then the 1 minus x squared was our u, so square root of u. And then I'm going to replace the dx with the du divided by negative 2x. This looks like this method is going to work because although I still have x's in the problem, notice there's one on top and one on the bottom. So we can actually cancel those x's out. The x's cancel out. We're left with an integral that's in terms of u only. That's a good thing. Now this is something I can actually integrate. Square root of u is the same thing as u to the 1/2. And then I'm going to take that divide by negative 2, that's a negative 1/2. I'm just going to pull that out front. And let's see, antiderivative, the negative 1/2 stays there. I add 1 to the exponent. So I get u to the 3/2 divided by 3/2, and then always plus c. Dividing by 3/2, I can flip that. It becomes a times 2/3. And then finally, I want my final answer to have x's in it. And so I did 2 things to get this last step. I did reduce the minus 1/2 times 2/3. That's 2/6 or 1/3. Or you can just think of it as we can cancel the 2's. So I'm left with negative 1/3. And then I replace the u with a 1 minus x squared to the 3/2 plus c. All right, let's do another one. Let's see if we can find the antiderivative of cosine x divided by sine to the 3rd x. So the first thing we have to do is to pick something to be the u. Now I think with these trig functions with exponents, I really like rewriting the sine to the 3rd of x as sine of x to the 3rd. It's a little bit easier for me to see that the inside function is actually sine x. Sine x is being cubed, that's my inside function. So I'm going to try letting u equal sine x. Then I'm going to compute my du. The derivative of sine x is cosine x, and then we need a dx. Now let's see if we can get this integral in terms of u only. I'm going to take my expression for du and solve it for dx. So divide both sides by cosine x. dx is du divided by cosine x. And then I'm going to plug things into that integral. So the sine x was my u, so that's how I got the cosine x over u to the 3rd. And then I replaced the dx with the du over cosine x. And once again, this is looking really promising. The cosine x's are going to cancel out. That's a good thing. That has to happen. This technique only works if you can get the x's to disappear. And so because the cosine x's cancel out, this technique is going to work. So now we're left with 1 over u to the 3rd. That's the same thing as u to the negative 3. This is something that I can integrate by adding 1 to the exponent. I get u to the negative 2 over negative 2 plus c. I'm going to move that u to the negative 2 to the bottom, so I can rewrite that as a 1 over negative 2u squared plus c. And then finally, I want my final answer to be in terms of x. So I'm going to replace that u with sine x. So I've got negative 1 over 2 sine x squared plus c. And you can leave your answer like this. This is great. This answer is perfect. I would probably leave my answer like that. But if you want, you could write that as -1/2 cosecant squared x. That's the exact same thing because cosecant and sine are reciprocals. All right, let's do another example. We want to find the antiderivative of x plus 3 divided by x squared plus 6x. So for this problem, I think it's a little bit less obvious what the u is. Maybe, I don't know. And so it's okay to just guess and try something, see if the u's cancel out, and if they don't, then just try something else. However, one thing to think about when you're trying to guess what your u is what's happening is whatever you pick for your u, you're going to compute its derivative, and that's what's going to do the canceling. Okay? So let me try to explain what I mean by that by doing this problem. So really, I see two choices for the u. I could make the numerator the u or the denominator. And I'm going to choose the denominator to be my u because the denominator has an x squared in it, and the derivative of an x squared will have an x in it, and that's what's on the top. So let's just see how that works. If that didn't make sense to you, that's fine. I guess what I'm trying to say here is sometimes you just have to guess what the u is, see if it works. If it doesn't, try something else. So let's see what happens when we let the denominator, x squared plus 6x, equal our u. We would compute the du, so the derivative is 2x plus 6. So du is 2x plus 6 dx. To solve for dx, we have to divide by the 2x plus 6. Okay, I'm going to rewrite my integral. So I'm left with x plus 3 over u, and I'm going to replace the dx with du over 2x plus 6. And so the goal is to get the x's to disappear. And so we actually can cancel out the x's, but we might have to do a little bit of work first. What do I mean by that? Well, we could factor a 2 out of the 2x plus 6. It becomes 2 times x plus 3. And now we can cancel those x plus 3's. And we're left with 1 over u, du over 2. Okay, so again, one thing to notice here is if your u has an x squared in it, hopefully there's an x somewhere else in the problem. If your u has an x to the 4th in it, hopefully there's an x to the 3rd somewhere else in the problem. So the idea is whatever you're picking for the u, its derivative, or a multiple of its derivative, should also be in that integral. And that's because the goal is to cancel the x's out. All right, this did work. We were able to cancel the x's out. So now we can integrate. We can pull that 1/2 out front. And we're left with a 1 over u du. Antiderivative of 1 over u is natural log of absolute value of u. So I've got 1/2 natural log u plus c. And then finally, for our final answer, we're going to replace that u with the x squared plus 6x. So final answer would be 1/2 natural log absolute value x squared plus 6x plus c. All right, let's just keep going with the examples. All right, so we want to integrate x times x minus 4 to the 7th. We're going to try to use a u substitution here because there is no product rule for antiderivatives, and I really don't want to expand that x minus 4 to the 7th. That would take forever. So first step is pick something to be the u. So maybe write down on your paper what you think the u should be. I would choose x minus 4 because that's my inside function. The derivative of x minus 4 is just 1, so my du is 1 dx. You don't have to write down the 1 though. Du equals dx. So let's see if we can get this integral in terms of u. So we've got the x, u to the 7th. Oh, dx is just du. Unfortunately, the x didn't cancel out. Our integral has x's and u's in it, and so we have to do more work. We cannot integrate until we get this in terms of u only. We have to get rid of that x. And so there's a little trick we can do here. If u is x minus 4, well then if I add 4 to both sides, if I solve for x, x would be u plus 4. So I can replace that x with u plus 4. And now I've got integral u plus 4 u to the 7th du. Now my integral is in terms of u only, which is a good thing. There's still no product rule for antiderivatives. However, I have taken something that was really hard to multiply, and now it's actually not hard to multiply. I can distribute the u to the 7th. I get u to the 8th plus 4u to the 7th. And this is something that we can integrate one term at a time. We end up with u to the 9th over 9 plus 4u to the 8 over 8 plus c. And then finally, we are going to replace those u's with x minus 4's. I also reduced the 4 over 8 to a 1/2. And there's my final answer circled.